Altså, man prøvede at få flere sådan officielle ting, men der blev ikke. Der var klogt i. Ja, så må man tage bussen. 10 på halv. Så op på 20. Så jeg tør ikke at jeg sagde, for at få mig i stedet.
So, 1218. Right. That's the cloud technologies class, or what the balance of it, I would say, rather. Is there any convention to start later, or is it just today, or is that the average class attendance level right now? I haven't been here last week, right? So I just wanted to hear what's going on.
So there was a presentation in Hama today.
Yeah.
Maybe some people left,
okay. Right.
But I don't think that there's that many. I don't.
Good. Okay.
I'm guessing it's just rain.
All right. Okay. Okay.
Yeah.
Well, anyway, it's streamed anyway, so no harm. Cool. So last week you probably heard about networking, right? So yes, no, perhaps socket programming, big fun. Did you do it in Go or any other language? C++ was the language of choice.
We didn't do any.
All right. You just were shown.
Simon showed
Cool.
us.
Cool. Yeah, that's good. But I hope you guys got an appreciation of what's involved when you do actually low-level socket programming, right? As opposed to the convenience that we have in Go, right? In Go, we usually just I don't know, open a socket and somehow magically we receive bytes and we can do stuff with it, right? So change them to strings and use them for our interfaces. Cool. So that sounds good. What I wanted to talk about is regular expressions. And the reason is mostly that as of now we got away. Well, in cloud computing, we generally it's all about building APIs, right? So you want to construct thorough APIs. Yeah, it's probably worthwhile to switch on those TVs if you haven't yet, so you see the slides to some extent. That said, there won't be many slides. We'll do a bit of hands-on stuff, or try, see how that goes. It always depends on the internet, isn't it? The idea is there that our input that we dealt with was firstly relatively programmatic and relatively structured, so we didn't have much complications in dealing with this. However, if we are dealing with custom user input, and an example of that one were you guys actually submitting stuff to us, right? So you provided us with student name, username, and URLs and so on, right? So it's always important to validate that particular content, right? With respect to your specific requirements that you write in your service. And since we're writing APIs, I think it's also important to get an understanding of what's involved to validate user input, especially manual user input, which is usually much more error prone as you can imagine, right? So cool. Did you guys hear about anything about input validation before in any other class? Just to give me a feel, because I don't know. Yep. Yep. So how did you validate there? What does it? Sorry? Okay. Okay. So how does the validation work there? Are you using regular expressions or?
I think I haven't put it in the source code.
Sure.
But I think it removes for escapes characters.
Ah, okay.
It removes in escape.
Right. So it strips invalid characters from a statement. Did you need to provide any sort of expression to do that, or just call that function and pass the input to it and then see what's happening? Or
So two methods. One is just POSIX function.
Yep.
And the other one is using prepared statements.
Ah, right. So yeah, you use prepared statements, right? So what's the key purpose about prepared statement? What's the key reason for using those? You said it implicitly. I just want to make it very clear. Yep.
I just to bind the input into the variables
Yeah.
to avoid direct input into this what is sent to database.
Exactly, right? So you want to bind the user or domain specific inputs or values or whatever else that you want to query or inject or whatever else to the SQL statements instead of having parsing SQL directly, right? So you kind of filter user input before combining it, effectively concatenating to SQL and executing it.
Yep. Kind of middleman that you don't need to, but you can make some efforts to check it.
Yeah, yeah, exactly. Well, in fact, I wouldn't say can, I would say you should, because that's number one, right? SQL injection is one of the key problems in security that we're dealing with, right? That you guys sending a drop table statement or something to an input field and well, cleverly surprised that the database actually lost its entire content or something like that. So no, there's always value in doing this, so it's good that you learn about it there. Here we're dealing with slightly different issues. Here it's more about filtering content with respect to specific well, syntax or expected input that you want to get, right? So classical examples generally include text retrieval. Well, we couldn't do a single string search, but sometimes you want to, for example, characterize a particular input as a date, right? And date, using string search to identify a date is probably not fundamentally easy, right? Because unlike looking for a specific string where you can just do string comparison, we actually need to do a bit of parsing, a bit of well, somewhat semantic checks to ensure that the meaning of whatever we represent here is possibly a date, right? So things like that. And I'm not sure if you know that that strip here. Not sure if you can read it. That's precisely the essence what it's about. So you have a massive amount of data, and for whatever reason, you need to extract a particular element of that one, right? So, and it's something like, for example, an address. You don't know the content, right? So you can't use a conventional string search, for example, if you're interested in an address, but you know the address format, right? How the address is a format in Norway, right? For example, right? So street name, house number, and then postcode, and so on, right? So just knowing the structure would be enough to actually do that. And that's precisely what it is about. And then syntactically, it often looks like something like that, which is not 100% intuitive, but at the end of that session, it possibly makes more sense. So we come back to that later. So and the idea there is to use regular expressions. And the reason I'm teaching them or referring to them is that they're fairly generic. You find the support for those in pretty much any language. So it's kind of an abstract syntax, which is programming language independent per se, that allows you to describe patterns of regular language, right? So instead of just doing a string comparison, you're looking for structural aspects of that language, patterns. And the idea is based on the work of Stephen Cole-Klein, who was actually involved in the or formalized regular languages in that very fashion. So, and by doing that, he also identified the structural patterns that we generally find when we write, especially, for example, human readable text and the patterns we use, and came up with a grammar or a way of describing those formally, so we can abstractly describe those structures or expressions. Yeah, so that's what we'll be dealing with. There are various standards that engage them. One of them is POSIX. And I think I used POSIX before the term, but I didn't really explain it properly. We'll do that in a second. And the other one is the Perl standard, pretty much. So Perl is a bit more dated, yet very reliable and often used programming language, which has its own flavor of regular expressions. And that is generally where the pain starts, because even though we look at the generic part of regular expression, the most commonly accepted one, a subset of that is specified in POSIX, but a lot of languages actually have their own little extensions, their own dialects basically, that build on those expressions. But just to get a clarification what POSIX actually stands for, and it stands for Portable Operating System Interface. We used that before. In what context did I mention that before? Anyone recalls?
Linux.
Yeah. Linux. Why? What was the particular thing about Linux there?
Since it's built on top of Unix,
Mm-hmm.
in the terminal, you talk with the operating system using the POSIX interface.
That's right. So yes, exactly. Most or not all, but many of the tools that you actually use on a terminal like ls, like chown, chmod. We talked a bit about this, where user permissions, browsing structure, cd, for example, and so on, are all specified as part of the portable operating system interface specification, along with other system calls that you can use to interact with the kernel or scheduler parameters and so on, are also in part specified by this POSIX system. The advantage is simply there, if you know the set of commands that are relevant to you, you can use them in all POSIX compliant operating systems. And there's quite a number of them. That said, POSIX has become a bit more, not so much a de jure, meaning not a legal standard as such, but rather a de facto standard. So most operating systems have some variants that kind of work with POSIX. So obviously Unix, Linux, they may not be certified, but generally adhere to those principles. In Windows as well, especially in the beginning where we tried, well, whatever mixed success, where we tried to set up the Ubuntu environment on Windows 10, right? So that also basically brings the POSIX standard to Windows in a widest sense. But there's also environments like SIGWin. Some of you may have used them before for compilation, right? Yes, no, perhaps anyone? SIGWin, MingGW, those ones? No? For native compilation on Windows for C++, for example. That's one way of doing it. But it's fairly compatible to most systems. So if you come across that, it's not just commands, it's a lot of architectural aspects of an operating system. So the standard is a bit horrible to look at. But as part of it, they also specify the regular expressions. So it's part of that idea as well. So the idea is that independent of your operating system, you should be able to use the same kind of expression to extract, for example, well, addresses or any other structural artifacts that you're interested in. And Perl is kind of the complement, has probably found a bit stronger adoption, especially historically, and this has led to its greater penetration and use in other programming languages. And Go is kind of sits in the middle there. It borrows a lot of, it builds on the POSIX standards, but borrows a lot of extensions. However, I was surprised that Go is surprisingly incomplete with respect to its regular expressions implementation as of now. So there's still a lot of things in the workings, but the most of the important things work. So I think we can have a go at it and look at it more carefully. So how does it actually work? And I probably exposed you to a bit of pain initially, and then we probably contextualize that a bit more and see how we can actually put that to use. So just some essential characteristics I think are the essential ones if we think about regular expressions. And the idea is there that we have notions of character classes. So we want to identify strings, for example, by their class, by their nature they actually represent. For example, are they digits? Are they alphanumerical character or just alphabetical character? Or are they special characters in particular? So we just want to characterize those. Here on top you find the top one is the POSIX syntax. It would write something like that. Squared brackets, colon digit. Note we have double squared brackets here. This is specific to Go in this example. In the original specification is single squared bracket. Alphanumerical in the second line here, for example, are the ones how they would be written in Perl. So same thing. So basically, digit, word, or word character, and this would be a space character or special white space character, basically, right? How you would express them. Then we have notions of repetition that we can express. So we can have indicate whether a statement or a character is optional, or we want to have one or more of those, or an arbitrary number of them. We have cardinalities, so the number, the constraint, the boundaries of a minimal number of characters that we want to have, or maximum number of characters. And we can also specify ranges, for example, for numbers as well as for alphabetical letters, which is quite helpful. We can group characters, and we can also identify alternatives. So for example, we want to have a string that either contains, or a number that either contains a 0 or a 9, we can test for that one. Or we can also exclude particular elements from a string. Yep.
What do you mean by
grouping? Yep. So you notice, so generally all the elements here that we're describing describe a single character. Yeah. So use the board. So twist the camera, see how that goes. If anybody checks the screen, please help. Please help me here. So if you, for example, indicate 0 to 9, right? So it allows any character from 0 to 9, but only one character. Yeah. So it's not an arbitrary number of characters. So if we want to, example, want to have one or more of those, we would say something like this, right? 0 to 9, at least one or more. Yeah. If we use the clean star or the asterisk, there you go. This would be 0 or more. And another alternative would be the question mark, which indicates 0 or 1. Yeah, only one. I call it character right now because the character class digit. So one digit or not, in fact. Yeah? So what you can do though as well is to, for example, have combine or construct your particular characters. For example, this way you'll be expressing, be able to express, well, double-digit character sets, right, for digits. So starting with 0 and here starting with 1, you would be able to express 0, 1, 0, 2, 0, 3. You get the gist, right? So, but only 2 digits. Yeah. So digit 1, digit 2. If you now want to operate or describe cardinalities for both of those, you would need to group them somehow. This is where the grouping comes in. Yeah. So we have the treatment of 2 characters, and there, for example, we accept those ones. Alternatively, we, for example, accept. I'm just making stuff up here. Yeah, okay, well, let's do it this way. This needs to be lowercase. We get to that in a second. So this one is the OR statement, you know that from your programming experience. So do you have it right? No, I'm missing a curly bracket, close bracket. So we have a 2-character set of, you know, alphabetical characters from A to Z, lowercase in this case. Note by default, regular expressions are case sensitive, right? So they're very particular about case. If I were to specify capital A to capital Z, then it's capitalized as well. If you want to specify both, you do something like that. This would mean either a lowercase or uppercase. Yeah? So that would be insensitive. So in this case, either 2 characters or 2 numbers. Yeah, that would be the expression you're getting here. And you get how it's getting increasingly complex from there. So generally you build this kind of approach from bottom up and then construct groups and define how often they can be repeated and so on. Yeah? So we start slowly there. But we start by example. It's probably easier than elaborating it this way. However, so I hope that clarifies the group thing, right? So so we can actually, you can actually also specify distinct values. For example, you want that your expression contains 1, 2, and 3. You just write 1, 2, and 3, right? If they're not wrapped into square brackets all alike, then literally would mean 1, 2, 3. So this expression would check for would either expect 1, 2, and 3 as part of its input, or any character from A to Z, lowercase. Yeah. So, yep. Yep.
This one, why does this have square brackets?
Yes. That's another. Well, there's not always only one way to write things, so you can do it multiple ways. In this case, what do you think it says?
1 character.
Yeah.
So I think that square brackets, you only can get 1 character.
Yep. Yep.
But you could also have normal brackets.
You could have, in this case, you actually can have normal brackets as well. It would say character 1 or character B. In fact, you would get away without brackets in the first place, as long as there's nothing around it. Right? So it really depends. But this would say 1 character either 0 or 9, similar as this, right? 0 or 9. Yes, but it really depends on the context, right? Because right now I'm just taking snippets and putting them there, so we can later use them, hopefully, to construct something more meaningful. Yeah. Cool. So we have that one. We have different alternatives. We have negation, right? We use this hat symbol at the beginning within the squared brackets to say, well, not those ones. So, not those characters. Yep.
All of them? Or just
one of them. Yep. One of them.
Just one.
Yeah, not 1, 2, or 3. Yeah, that's I think so. Yeah. They are in this case. Let's take it. All right. It's probably a good point to start hacking. So let's write some expressions and try that all out. So in Go we have a built-in regular expression library. It's called regexp, and we can invoke it directly by matching a. That's hardly legible, I suspect, right? Is it? I'll increase the size a bit. Give me a second, please. And then we establish that 20 would do. Right. Right. So that's the default input. We need to specify some sort of pattern. So let's do that. Generally, any input that's received is of type string, right? Even if it's a number, numeric value, you test it as a string first, yeah? And then you would convert it into a number. For example, you want to figure out that a particular user input is of type has a particular structure. You do your input validation first, and if that works out, convert it to string. Yeah, that's why how you receive it from, for example, HTML forms anyway. All right. We want to have some pattern. So what was our pattern? So not something that has a 1, and then let's follow it by a value from 0 to 9. That looks about right. And just to make our representation a bit more abstract, let's use an input that is 1, 2, 3. So cool. What does match string return? Boolean and an error. So let's be a bit lazy and ignore the. Well, let's use the error as well in case. If error exists, then let's print something out. Error.error interface. Cool. So, and then we print res. Res at this stage should be a Boolean. So, right. So, does everyone follow roughly what's happening here? Yep, quite straightforward, right? You wrote way more code than I did just now, so that should be easy. Cool. Right. So, what do we see? Right now, right, we have an input 1, 2, 3. We have the regular expression that matches against a particular pattern or representation. So I'll make it even larger. Hang on. It's probably more legible then. I notice some people are squinting here, so there's no point. Let's see. As long as I still see something on the screen, that's probably. Ah, yeah, that's probably better. So, cool. And then we have the pattern that we. Hang on. We don't want to have a 1 there. That's not good, right? And then followed by 0 or 9, and we have a particular input we're matching against it, and the whole program says result. It says true, which is not good. Hang on. That brings me back to my usual problem. We need to figure out how far the syntax is supported. Hang on. So when we look at just to get you an insight into the syntax representation, it's I will link it as part of this session anyway. This is the syntax that's as far as supported by Google. So Google and then the repository re2, which is the official syntax for regular expressions in Go. So negated character class. So that's supported. So we shouldn't have any problems there. Let's bring back up. Like this one. Matches anything. Yep. What do I miss? Oh, yeah. We didn't talk about this yet. So I come back to it in the second view. Yep.
I'm just wondering, don't you need to set up this the one that you're not accepting is the first character that is part of the string with this one?
You mean the head?
This starts with.
You mean this one?
Yes.
Right. That's what I want to get at. You're kind of on the right track here. Yes. So let's run this one and then see what happens here. Cool. Finally, we have a false. I'll just remove this one, and then we're on the right track. Hang on. So. Good. So yeah, spot on. So you kind of gave, both of you had the same solution at the same time. So what I didn't do, I specified I'm looking for a well, some string, right? So which doesn't have a, probably to return this one here. No. That doesn't have a leading one, and it has another character 0 to 9, right? So what I didn't specify, however, is that I want the string to start with that very rule, right? So and also possibly to end. So if you want to indicate that this string should check from the start of the particular, or ensure that all matching strings are actually starting with that particular requirement, then you will need to set a head outside. You need to indicate the word boundaries as well. Similar for termination. If you, for example, only accept a given number of characters, you also need to terminate it to indicate that it actually should end here, the particular string, right? So it's quite important, because otherwise it will potentially match substrings within your entire input, as pointed out there. Thank you very much. So let's run this one, and it's probably also false. Let's see how far we need to get to actually make it matching again. Again, the output is down here, false, for anyone who isn't following. So let's fix the rule, not start with a 1 to some extent. It's still false. And only now it becomes true. So what happens if we remove one more? Cool, it becomes false. So this statement is exactly looking for two characters. The first one must not be a 1, and the second one anything from 0 to 9. That's the key idea. So now we are playing with your rule, and saying we don't want to have a 1 and 2. That's not happening, so we need to check. We can manipulate around this. So there you go. So it checks for character 1 or 2. They must not exist in the first particular character, right? So again, the character is surrounded by the square brackets. We're saying not 1 and 2. That must be the first character, and 0 to 9 the second one. Does it make somewhat sense? Who is not convinced yet? Who is confused? What's going on here? We'll explore with this more. It's just a starting point since we had the question here. Everyone good so far? Yeah? Okay, cool. So that'll be one way of actually testing it. So just to clarify that, because I put this here as well, again, the word boundaries are delimited outside of those square brackets using the head symbol again, meaning that's the start of a word, and the $sign terminating a particular term. In POSIX syntax, you can also say /b, it's a word boundary. So you want to delimit a word there so that you're only accepting words in this brand. Yep.
And just to be clear, so it means something else when it's a boundary. It
That's correct.
Negation.
That doesn't mean negation, exactly. In this case, it means start, right? So,
Yep.
so
that's only when it's at the beginning of the string.
That's correct. Yeah, so it's outside at the beginning of the string. You're very right. Yes. Yeah. Thanks. Yep, and $sign at the end. So those are the general one. Note again, treat it with care. It really depends on the language you're using, because some of those symbols may be reserved for a particular language, and they may be very fussy about it. So oftentimes you need to actually work with escape characters. So usually backslash to ensure that the term is not simply interpreted by the language as opposed to the regular expression compiler, right? So it's quite sensitive there. Particular, for example, in Bash, you can use regular expressions in Bash, and perhaps we have a chance to look at it tomorrow. But the idea there is you need to pretty much escape everything you do, so it looks horrible in code in practice, but kind of works, I guess. Cool. So just to summarize the scary characters we need to be mindful of. Those are the meta characters denoted down here. So those all have meaning, right? So the head either means negation or start of a term. The $sign means refers to the end of a particular character or string in this case. Then we have the squared brackets that identify options for a given character in a given position. We have the parentheses for grouping. We have the asterisk for multiplicity, so 0 or more in this case, and the plus for 1 or more, question marks for 0 or 1, which kind of hopefully makes sense, and the pipe symbol for or, right? And again, the full stop means any character. So so in fact, if you want to write a regular expression that kind of matches any character, you can do something like this, right? So one character of any flavor, of any type, and this for an arbitrary number of times, right? So that would match pretty much any sort of string you possibly get. Probably not particularly useful, but you know, that's the most generic filtering you can do. Note that regular expressions per se are case sensitive, so something really to be mindful about. And I mentioned that briefly up there before. If you are mixing, in fact, it's I think here as well. If you want to mix upper and lower case, that's fine. You just need to be explicit about it. Yeah. So in your specification, if you don't want to have that tested, and again, it depends on the flavor of regular expressions you're using, you would need to prepend or have a prefix of question mark I, which sits in front of the entire expression. That would make it case insensitive. Yeah, that's how it works in Go at least. So that's one way. Cool. Anything else important?